Hello students, today very important we are going to discuss derivation of vector identities. Very important, very simple. We just see few vector identities, very simple. There are some properties related to various meaningful combinations of gradient, divergence, curl and Laplacian. These are established by taking a general scalar point function over a vector point function. So this has to be remembered for working certain types of problems, students. Immediately we'll go to derive. Yes students, here you can see very simple vector identity 1. So you can see just they ask the question in the exam, prove that curl of gradient phi is equal to 0. Yes students, please substitute the formula and definitely you will get the answer. So here we go. So here we start the problem. I say that proof. Very simple students. Just substitute. You can see what is first. I will solve gradient of phi. So whenever you get such type of problems, you first substitute the formula. So just I take this gradient of phi, which is equal to, students, please remember gradient is nothing but del phi. So we have discussed gradient in the previous lecture. You can get the link in the description box, students. So gradient of phi is equal to del dot phi. So we have discussed scalar product function, vector field. So all the formulas I have given in the previous video, you please go through it. So this is equal to, just substitute the value, it is dou phi upon dou xi plus dou phi upon dou yj plus dou phi upon dou zk. Yes friends, this is the formula you have to remember. Now after writing this, I will find curl of gradient of phi, that is our LHS is equal to RHS, students. Okay, so without wasting your time, please write down curl of gradient of phi. So definition of curl, definition of gradient, definition of divergence, all have discussed in the previous video, students. Please go through it once again. Now curl is nothing but, please remember, this is a cross product, and del phi we have already calculated here. So just I will take it in this is del phi. Okay, so here you can see, students, what is del phi is going to become this cross product. I am going to take this as I, j and k. Please remember this, students, I, j, k determinant. Okay, simply substitute the values, dou upon dou x, dou upon dou y, dou upon dou z. Here you can see in the cross product, remember the formula f1, f2, f3 already discussed previous video. You can go through this. I will consider f1, this I will consider f2, and this I will consider f3. So I, j, k, I'm going to substitute the values in the formula directly. It is dou phi upon dou x, dou phi upon dou y, dou phi upon dou z, students. This is what we have substituted the value. Okay, one by one we are going to simplify this. So here we can see this is equal to I. Yes, please remember the determinant formula. If you don't know the determinant or formula, please go to the previous lecture. There I have discussed determinant formula also. So first I will take I. Please leave this row and column. You can see you are going to multiply dou upon dou y into dou phi upon dou z, then minus dou upon dou phi dou z into dou phi upon dou y. Then minus j. When we take minus j, please leave this row and column. Multiply this element, students. Dou upon dou x into dou phi upon dou z minus dou upon dou z dou phi upon dou x. Now I will continue with the plus k. Leave this row and column, students. So I will take this as dou upon dou x dou phi upon dou y minus dou upon dou y into dou phi upon dou x. So just we have cross multiplied this. So using determinant formula we will get this equation. Is it clear, students? Now here you can see you can simplify this one by one. So this I will write it in this way. I into, so dou into dou is going to become dou square phi. This is dou square phi upon dou y dou z minus, here we can see as students, dou square phi divided by dou z dou y minus j dou square phi divided by dou x dou z minus dou square phi divided by dou z dou x plus k into dou square phi divided by dou x dou phi minus dou square phi divided by dou y dou x. Yes, friends, where you can see here very easily that whenever you get dou square phi divided by dou y dou z, just they have interchanged here role of dou y and dou z, here dou z and dou y. So it is multiplied, it is like 2 into 3 or 3 into 2. So this values automatically will become 0. Is it clear, students? So therefore this answer is 0, which is our RHS. So here visually we can see, students, that thus we say that curl of gradient of phi is equal to 0, or RHS is equal to LHS. So this is the proof, very important for examination point of view. Immediately we'll go to the next one, students. You can see here, prove that divergence of curl A bar is equal to 0. That's it, students. They have given the question and answer itself. So okay, so we'll prove this now. Very simple. First you take curl of A bar, then you simplify one by one. So first I will take let A bar is equal to A1i plus A2j plus A3k. Okay, so we'll simplify this ones. So here we have curl of A bar is equal to, this is, please remember, curl is always a cross product, del cross A bar, which is equal to I j k dou upon dou x dou upon dou y dou upon dou z. And here you can see, students, here f1 f2 f3 will become a1 a2 a3. So this formula I have discussed in the previous lecture. Please, you can go to the previous lecture and you can watch how this formula has been done, what is the definition, and how we have substituted the values. So then this is equal to, students, again we are going to simplify the determinant. Let's say this is plus minus plus, so I will take I dou y a3 divided by dou y minus dou a2 divided by dou z minus j dou a3 divided by dou x minus dou a1 divided by dou z plus k dou a2 divided by dou x minus dou a1 divided by dou z. So here we get I, j, k. Easily one can simplify this, friends. And now we see this is curl of a bar. Okay, so now what they have given in the question, it is divergence of curl of a bar is equal to 0. Is it clear? Sometimes in the exam, students, they make you confused and they put it like this. This is del dot del cross a bar is equal to 0. It is the same, students. Here you can see dot product is nothing but divergence and cross product is nothing but curl. So please see that you don't make mistake in dot product and cross product. Dot product and cross product we have already discussed in the previous lecture. Please go through that video. You will understand how del dot del cross a bar is equal to, you are going to simplify. Okay students, now one by one you are going to take curl of a bar. We have already calculated. Now we are going to take divergence of curl of a bar, which is equal to del dot del cross a bar. So already we have discussed del cross a bar. Here we have already done, half work is done. Okay, we'll take same way and take it as multiply with del. Okay, so here we can see as friends, this is equal to, please substitute the value of del, dou upon dou x I plus dou upon dou y j plus dou upon dou z k. Then dot product, here I am going to take I dou upon a3 y minus dou upon a2 dou z minus j dou upon dou a3 upon dou x minus dou a1 divided by dou z plus k dou a2 divided by dou x minus dou a1 divided by dou y. This is what we have to do the dot product. Where you can see easily that I into I is going to become 1. So corresponding elements will be multiplied, I with I, j with j and k with k. We are going to simplify this one. So here we can see obviously after using the dot product you are going to get the values in this form. So expanding this value, students, that implies dou square a3 upon dou x dou y minus dou square a2 divided by dou x dou z plus dou square a1 divided by dou y dou z minus dou square a3 divided by dou y dou z plus dou square a2 divided by dou z dou x minus dou square a1 divided by dou z dou y is equal to 0. Thus, yes friends, we have proved that divergence of curl of a bar is equal to 0. So please remember this one. This can be also given in the exam. Del dot del cross a bar is equal to 0. This is dot product, you use it, and this is cross product. Yes students, very important identity we have calculated. So now we'll go to the next one. Yes students, so vector identity 3. Now this is very important, and here you can see little bit twisted. The question they have twisted it is, prove that curl A bar is equal to gradient of divergence A bar minus del square A bar. Yes students, here you can see they are little bit twisted, so don't get confused. We'll simplify this very easily. So please take here proof. So first you write down A bar. So A bar we are going to consider this as A1I. You can take any value A1, or you can take F1, right? You can take any other value. So A1I plus A2J plus A3K be a vector point function of x, y, z. Please remember this is a vector point function. Vector point function x, y, z. Okay, so we'll start taking the LHS. We have to prove always LHS is equal to RHS. Okay, now I'll take curl of A bar. So to prove this LHS, I will take first curl of A bar. Please remember curl of A bar is nothing but del cross A bar, which is equal to I j k dou upon dou x, dou upon dou y, dou upon dou z. A1, A2 and A3. Yes students, please remember, simplify this values. So this is going to give you I into, so please remember this is plus minus plus, so I into dou upon dou y A3 minus dou upon dou z A2, then minus j dou upon dou x A3 minus dou upon dou z A1 plus k dou upon dou x A2 minus dou upon dou y A1. This is what we have calculated the value students. Here you can see there is one shortcut way to remember this. I will tell you one shortcut way. This is also written as summation I. Yes students, this sum of all I with respect to dou upon dou y A3 minus dou upon dou z A2. Yes students, this is equal to this thing because this is sum of all I j k. We always take sum of I is nothing but I plus j plus k. This is what you have to remember. Next, if suppose summation A I is there, A1 I is there, so here you can see this is A1 I plus A2j plus A3k. For our simplification, I have taken it, made it very short so that in the problem we can easily substitute the values. If you want, you can write it in this form, no problem. Now I am going to take curl of curl A bar. Yes students. So now I am going to take curl of curl A bar is equal to del cross A bar. Already we have calculated del cross A bar students. Just substitute here. Now this is going to become I, j and k dou upon dou x, dou upon dou y, dou upon dou z. Yes students, you can see here that here we are going to substitute a1, a2, a3, but see this is going to become a1, a2 and a3 beside I, beside j and beside k. I am going to substitute in this. So this is going to become dou upon a3, dou a3 upon dou y minus dou a2 upon dou z. Next here I am going to substitute dou a1 upon dou z minus dou a3 upon dou x. Next I am going to substitute dou a2 upon dou x minus dou a1 divided by dou y. Just I have substituted this value. This is also considered as f1, f2, f3, which is beside I, j and k. Please remember this students. Okay, so now again substituting the values and rearranging, you can see this can be written in short form, that is summation of only first term. I will write summation. It means that it is continued to j and k. So this is summation I dou upon dou y, dou a2 upon dou x minus dou a1 divided by dou y, then minus dou upon dou z, dou a1 upon dou z minus dou a3 divided by dou x. Summation means students, please remember, if I take summation I means it is equal to I plus j plus k. So sum of all means plus minus plus itself, you will get this value. So you can see, in order to get del square in the second term, and observing that we do not have the second order partial differential equation, you must think of adding and subtracting the same. Yes students, please remember, now we don't have any partial differential equation second order. We do not have the second order partial derivative. So therefore what we are going to take, I am going to modify this equation, adding and subtracting summation I dou square a1 divided by dou x square we get. Yes friends, I am just going to add and subtract here this equation. So immediately I will get the value as summation I. So I will just add these values, dou square a1 divided by dou x square plus dou square a2 divided by dou y dou x plus dou square a3 divided by dou z dou x minus summation I dou square a1 divided by dou x square plus dou square a1 divided by dou y square plus dou square a1 divided by dou z square. Yes friends, so we will get in this form. So next I will take out the first dou upon dou x outside from this first term, and from this I will take summation I as it is. So this is going to become students summation I dou upon dou x is common in this first part. So therefore I just take this as dou upon dou a1 dou x plus dou a2 divided by dou y, dou x is outside, so this is again plus dou a3 divided by dou z. Is it clear, students? Here you can see in this part a1 is common, so I just take this as minus summation dou square upon dou x square plus dou square upon dou y square plus dou square upon dou z square. A1 I have taken it outside, students. So you can see I have done it very simple and very short. I have simplified it, and remaining part keep in your mind, students. So summation is nothing but summation I plus j plus k, it is always there, but this is in short and very easily you can simplify this. So next step you can see, yes friends, this is equal to, yes, this is going to become summation, this full term, if you take ijk and dou upon dou x, if I keep it outside, so dou upon dou x I will keep it outside. This ijk dou upon a1, dou a1 upon dou x plus dou a2 upon dou y plus dou a3 upon dou z is going to become divergent of a bar, which is I. So please remember this, friends. This dou upon a1, dou a1 upon dou x plus dou a2 upon dou y plus dou a3 upon dou z is dot product of divergence a bar. A bar is a1, a2, a3. So here we get I as it is. So this is the first value. Then minus, yes friends, here you can see dou square upon dou x square plus dou square upon dou y square plus dou square upon dou z square is nothing but del square from the Laplace equation. You can just go through the previous lecture. I have given the formula here. So here we can see by using formula from previous lecture, I am going to take this directly. So this is going to become just summation, I will take del square a1 I. Yes friends, I will take a1 I. This is how you have to simplify very easily. You can see we will get the answer. Now you can see, yes friends, this summation dou upon dou x, summation dou upon dou x is considered as gradient. Yes friends, so I just take this as gradient, use the formula a bar, that's it friends, minus dou square, please consider this a1 I is equal to nothing but a bar. So here we can see a bar is nothing but a1 I plus a2 j plus a3k, which is nothing but summation of a1 I. That's it. So therefore this is going to become a bar. So thus, yes friends, curl A bar is equal to gradient of divergence of a bar minus del square a bar, friends. So this is how we have to simplify. Some more identities are there. In the next video I am going to discuss the next identities. So please go through this identities once again, practice the problem. I have made it very short and very sweet. You can easily digest the study material. Yes friends, thank you so much.